Hello friends, Satyendra here, and in this video, let's create a helical curve, a conical helical curve, and a spiral curve in Creo Parametric. So let's get started. And for this, I'll use curve from equation. Now once you complete these curves, you can use these curves for several purposes. So I'll begin with the helical curve. And for this, first I'll create a new file. So go for new, part, solid or sheet metal, assign the name and say OK. Now to create the helical curve, first you go to datum, curve, curve from equation. Now here you have three type of coordinate system, Cartesian, cylindrical and spherical, but I'll use cylindrical coordinate system. Now for reference, you need to select the existing coordinate system. So I'll go with this one. So once this is selected, go for equation. Now here you write down your expression first in terms of r, theta and z. R for radius, theta is for angle and z for the depth. Now here you have a term called t. So t is the independent variable which varies from 0 to 1. So don't worry about t. Just write your expression in this format and verify it. So it says that relation has been successfully verified. Say OK. If your relation is having any error, then it will show the error. Now say OK. So it is generating a helical curve. This is the z direction. Now say OK. Now let's cross check this curve, and for this I'll go for sketch, onto the top datum plane, sketch, normal. Now create a reference, select this point, then draw the line. Now I'll add a few dimensions. So I have added 2 dimensions here. Now I'll say OK. Now if you edit the sketch, you have 2 dimensions. This is the radius 50 and this is the height 100. So now if you edit this curve and go to the equation, see z direction, the height is 100 and that is why you are getting this value 100, and radius is 50 and that is why you are getting this radius 50. Now theta is 360 into 10. So 360 degree is a complete revolution. So this is 10 numbers. So if you see from here, first revolution is still here, then second, then third, then fourth, then fifth, then 6, 7, 8, 9 and 10. So since it is a constant radius, we have R50. If the radius is varying, then it will become a conical helical curve, and in that case, this radius value will change. The rest of the things will be as it is. So if I write radius 50 plus t into 50, and then I'll verify it and I'll say OK. Then you will see a different result. Now this is becoming conical. This is just because now your radius start with 50. So here it is 50 and gradually it is increasing. So this 50 in addition with this 50 is the biggest radius. So now you say OK and OK. Now if you edit the sketch, this is 100, and if you define this gap, this will be 50. So 50 is the initial radius and 50 plus 50 become 100 here. Once again go to the curve, So if you write here into 100, then this radius will become 150. Now 360 you understood, this 10 you understood, this is the number of count, and this depth is 100. Now if I make it 50 and say OK, see, the height is reducing. If I make it 500 and say OK, see. So let's make it 100 again. And say OK. So now you have the conical helical curve. Now the same curve, if I remove this z value and make it 0, then this will become a spiral curve. Because the z direction is 0, so there is no depth. So the entire sketch is in the same plane, and that is why it became a spiral curve. So now if you go to the equation and check it, see r50 plus t into 50. So the initial radius is 50, but the final radius is 100. Theta is 360 into 10 numbers. So if you count from here, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and z is 0. So this is how we create helical curve, conical helical curve and spiral curve using cylindrical coordinate system in Creo Parametric, and I hope this video will be helpful. Now like the video if you find this video helpful, and I'll see you in my next video. Thank you.